Good morning. Our topic for today is all about modern geometry. So, modern geometry is the opportunity for the student to connect and apply their knowledge of art and perspective of drawing. So, our first topic is all about axiomatic system and finite geometry sample. So, axiomatic systems is any set of axioms which some or all axioms can be used in conjunction to logically derived theorems. So axiomatic system is a set of axioms that can use to be a conjunction to logically derived theorem. So ang makaderive siya theorem, so ito na mga axioms is makaderive siya theorem. So the first, so finite geometry samples. So finite geometry is any geometric system that has only a finite number of points. So the first example of the finite geometry is the 3-point geometry. So 3-point geometry is composed of the axioms and theorems. The first axiom of the 3-point geometry is exists exactly 3 points. So an axiom is there are only 3 points. Then the second is two distinct points are on exactly one line. So the two distinct points is exactly in one line. Then not all the 3 points are collinear. So not all the 3 points are collinear. Then the two distinct lines are on at least 1 point. So and two distinct lines is are on at least 1 point siya. Then the theorem is there exist exactly 3 distinct points. So ang 3-point geometry is composed siya of there exactly 3 distinct points and theorems niya. Then second is each 2 distinct points are on exactly one line. So mo to siya. Then not all the points are on the same line. So dili tanan points is na at the same line. And each 2 distinct lines are on at least 1 point. So ang each 2 distinct lines niya is at least at 1 point. Then sa man siya example. O di ba na siya 3 points tapos example of the 3-point geometry. So there are 3 exactly points sa 3-point geometry. So man siya 1, 2, 3. Then next is the 4-point geometry. So 4-point geometry is composed of exactly 4 distinct points ang axiom niya. There are exactly 4 distinct points. Then any 2 distinct points have exactly one line. So any 2 distinct points have exactly one line. Then next is each line is exactly on 2 points. Then the theorems are if 2 distinct lines intersect, they contains exactly 1 point. If the 2 lines intersect, so isa ra gyapon na siya ka 1 point, nag-contain lang na siya og 1 point. Next is there are exactly 6 lines. So there are exactly 6 lines sa 4-point geometry. Each point lies exactly on 3 lines. Each point lies exactly on 3. So each point is lies sa 3 lines. Each distinct line has exactly 1 line parallel to it. So each distinct line has exactly 1 line na parallel siya. Then this is the example. So 1, 2, 3, 4. Then ang lines is 1, 2, 3, 4, 5, 6. So in each 3 lines na siya 1 point. Then next is the 5-point geometry. Axioms. The axioms of 5-point geometry are there exist exactly 5 points. 5 points kani siya 5-point geometry. So there exist exactly 5 points. Then each 2 distinct points have exactly 1 line and both of them. So each 2 distinct points have exactly 1 line lang gihapon siya. Then each line has exactly 2 points. Then sa each line na siya 2 points. Then the theorems are each point geometry has exactly 10 points. Then each point of the geometry has exactly 4 lines on it. Let's see sa example. So mo siya example na siya 10 points. Exactly 10. Siya 5 points. 1 1 2 3 4 5. Then mo to siya. Then each point is in exactly 2 lines. Di ba na siya 2 lines? Then 1 point lang siya. Ano siya. Next is 4-line geometry. The 4-line geometry is, the assumption is there exists exactly 4 lines. Then any two distinct lines have exactly 1 point on both of them. Then each point is on exactly 2 lines. So in each point is exactly on 2 lines. So kada points niya is nagalay siya sa 2 lines. Then there exists exactly 6 points. Each line has exactly 3 points on it. 4-line geometry. Each line has exactly 3 points on it. Let's see sa example. So, mo ni siya. Example sa 4-line geometry. So, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Mo ni siya 4 lines. 1, 2, 3. 4 points. 1, 2, 3, 4. Pero, nag-exist siya 6 points. 1, 2, 3, 4, 5, 6 muna siya. Ito siya ang 4-line geometry. Then, in each two lines consists of 1 point lang siya. Next is the Fanus geometry. Fanus geometry, there exists at least 1 line. Every line has exactly 3 points on it. Not all the points are on the same line. For 2 distinct points, there exists exactly 1 line on both of them. Each 2 lines have at least 1 point on both of them. So, ang Fanus geometry, there exists at least 1 line lang siya. Then, every line has exactly 3 points on it. So, in every line, na siya 3 points on it. Then, not all the points are on the same line daw. So, not all the points are on the same line. Then, for 2 distinct points, there exists exactly 1 line on both of them. So, for 2 distinct points, there exists exactly 1 line. So, 2 distinct points na siya nag-exist na 1 line on both of them. Then, each 2 lines have at least 1 point on both of them. So, each 2 lines have at least 1 point sa both of them. Then, the theorems are, each 2 distinct lines have exactly 1 point common. There exists exactly 7 points on 7 lines. An example of an axiomatic system that is not categorical. So, ang Fanus geometry is not categorical. Then, ito siya, example is, muna siya ang model for Fanus geometry. So, 7 lines, 7 points. 1, 2, 3, 4, 5, 6, 7. 7 points. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7 lines and 7 points ang Fanus geometry. Next is the Young's geometry. Young's geometry is, the assumptions are, there exists at least 1 point, at least 1 line. Then every line of the geometry has exactly 3 points on it. So in every line, there are 3 points, has exactly 3 points on it. Then not all points of the geometry are on the same line. Then for 2 distinct points, there exists exactly 1 line on both of them. If a point does not lie on a given line, then there exists exactly 1 line on that point that does not intersect the given line. Next is the theorems. For every point, there is a line not on that point. For every point, there is a line not on that point. For every point, there are exactly 4 lines on that point. Each line is parallel to exactly 2 lines. There are 3 lines, no two of which intersect. There are exactly 12 lines. There are exactly 9 points. No mo to siya. Composed siya 12 lines and 9 points. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 points and 12 lines. Ano siya? Ang Young's geometry. Our next topic is all about Euclidean geometry and basic ideas of non-Euclidean geometry, with special emphasis of hyperbolic. So, Euclidean geometry is a mathematical system attributed to Alexandrian Greek mathematician Euclid, which he described in his textbook on geometry, The Elements. Euclid's methods consist in assuming a small set of intuitively appealing axioms and deducing many other propositions from this. So, ang Euclidean consists of a small set of intuitively appealing axioms. Mao to siya. And deducing many other propositions. The non-Euclidean geometry is literally any geometry that is not the same as Euclidean geometry. Although the term is frequently used to refer only to hyperbolic geometry, common usage includes those few geometrics, hyperbolic and spherical, that differ from but are very close to Euclidean geometry. So, ang non-Euclidean is composed siya of hyperbolic and spherical geometries. Next is Euclid's postulates. You can draw a straight line from any 2 points. The next is straight lines can be extended forever in 2 directions. If given a line segment, you can draw a circle having the segment as the radius and the endpoint as the center of the circle. Then, every right angle is congruent. So, every right angle is congruent. 2 lines are intersected to a third sum of the inner angle, but there will be less than 2 right angles. Example, muna siya ang example sa Euclid's postulates or Euclidean geometry. This siya. Next is spherical geometry. Postulates. It has positive curvature. Lines are curved. Each line forms a circle. The total measure of the angles in a triangle is more than 180. Then there has no parallel line. So, mo to siya ang postulate sa spherical geometry. And sa hyperbolic geometry it has negative curvature. So, ang Euclid's postulate is every right angle is congruent. Then, kaan siya? Straight lines can be extended forever in 2 directions. How about the it has positive lines are curved it has positive curvature. Each line forms a circle. Total measure of the angles in a triangle is more than 180 degrees. There has no parallel line. And the postulate of the hyperbolic is it has negative curvature. Lines are infinite. A line is defined as an arc drawn in the Poincare disk. Hyperbolic geometry is the postulate. It has negative curvature and lines are infinite. A line is defined as an arc drawn in the Poincare disk. The total measure of the angles in a triangle is less than 180 degrees. 2 intersecting lines can be parallel to the third line. So the difference of the spherical and hyperbolic is in spherical it has positive curvature, then the lines are curved, and the total measure of the angles in a triangle is more than 180 degrees. How about the hyperbolic is ang line niya is negative, it has negative curvature, then lines are infinite, and the total measure of the angles in a triangle is less than 180 degrees siya. Ito siya example sa hyperbolic geometry. Next is symmetry. Symmetry in everyday language refers to a sense of harmonious and beautiful proportion and balance. In mathematics, symmetry has a more precise definition and is usually used to refer to an object that is invariant under some transformation, including translation, reflection, rotation, or scaling. So, there are 3 different types of refer to an object ang symmetry, and that is invariant under some transformation, including ang first is reflection symmetry. Reflection symmetry is the simplest symmetry. It is sometimes called mirror symmetry. It is to see because one half is the reflection of other half. So mo ni siya example of reflection geometry na reflect ang volcano sa pikas sa half side niya. So mo na siyang reflection geometry na nag-reflect ang pictures sa half niya, sa other half. For like example yung sa mirror. Then next is the point symmetry. Point symmetry is when every part has a matching part that is the same distance from the central point but in the opposite direction. It looks the same when viewed from opposite direction, such as left versus right, or when turned upside down. It is sometimes called origin symmetry. So ang point symmetry is nag-meet sila sa center din. Di koan siya. It looks, tanaw mo siya, murag same lang sila diri pero dili siya high, opposite ang ilahang direction. Dito siya padulong din kani siya sa pikas. Then nagmeet sila sa point there sa center. Then next is rotational symmetry. When an object is rotated in a particular direction around a point, then it is known as rotational symmetry or radial symmetry. Rotational symmetry existed when a shape turned and the shape is identical to the origin. So rotation is that nag-rotate ang picture. Nag-rotate siya. Maong gitawag siya rotational symmetry. Next is the isometry. Isometry is a distance preserving transformation between metric spaces, usually as assumed to be objective. So nag-compose din po siya transformation. First is rotation and reflection and translation. So same lang gihapon siya. Reflection is nag-reflect. Figure flips over a line. So ang figure is nag-flip siya over a line. Then ang translation is nag-slide siya in any direction. And rotation is rotate siya figure turns about a fixed point. Then dilation is figure is enlarged or reduced. Ang picture niya is may siya tapos gi-reduce lang siya padako, pa-enlarge. Next is the projective geometry. So the axioms of projective geometry is if A and B are distinct points on a plane, there is at least one line containing both A and B. So if the distinct points on a plane, there is at least one line containing both A and B. So naa lang siya one line sa A and B if A and B are distinct points on a plane. The next is if A and B are distinct points on a plane, there is not more than one line containing both A and B. So if A and B are distinct points on a plane, dili siya more than one line containing both A and B. So isa lang siya. Then any two lines in a plane have at least one point of the plane, which may be the point at infinity in common. So any two lines in a plane have at least one point. So any two lines sa plane, at least nara siya one point of the plane. The next is there is at least one line on a plane. So in a plane there is only one line. So every line contains at least 3 points of the plane. So in every line contains 3 points of the plane. All the points of the plane do not belong to the same line. All the points of the plane do not belong to the same line. So tanan points sa plane is na siya nagbelong to the same line. Next is theorems and principles of projective geometry. First is sumani siya ang example sa projective geometry. Then gi-reflect siya ba tapos isundog. Then theorems and principle. First is duality of principle. Next is the Theorems and principle of projective geometry. First is the duality principle. Duality in mathematics principle whereby one statement can be obtained from another by merely interchanging two words. It is a property belonging to the branch of algebra known as lattice theory, which is involved with the concepts of order and structure common to different mathematical systems. All the propositions in projective geometry occur in dual pairs which have the property that starting from either proposition of a pair, so mo to siya, di ba, duality, then the other can be immediately interfered by interchanging the parts played by the words point and line. So the principle was enunciated by John. Similar duality exists for reciprocation as first enunciated by Poncelet. So, ang duality of principle is, so in the projective geometry of the plane, the words point and line can be interchanged, giving for example that the dual statements. So mo to siya ang duality of principle is, for example, inya is the words point and line can be interchanged, giving for example the dual statements, the two, so the changes sa duality mo ni siya, 2 points determine a line and 2 lines determine a point. This mo to siya ang pag-change sa state sa projective geometry of the plane to dual statements. Next is the Pascal's theorem. So the Pascal's theorem, it states that given a irregular or hexagon inscribed in a conic section, the three pairs of the continuation of opposite sides meet on a straight line called the Pascal's line. So the three pairs of the continuation of opposite sides meet on a straight line pagkato siyang 3 points na opposite sides meet on the straight line, it is called the Pascal's line. Mao to siya, Pascal's theorem. Pag mag-meet tong 3 opposite sides into a straight line, it is called Pascal theorem. Next is the Bryanton's theorem. So the Bryanton's theorem, it states that he gave in a hexagon circumscribed on a conic sections, the line joining opposite polygon verticals meet in a single point. So mo to siya, the lines joining opposite polygon nagamit siya sa in a single point. So mo to siya ginatawag na Bryan's theorem. This topic is all about chaos theory and fractal geometry. So chaos theory is a branch of mathematics focusing on the study of chaos, dynamic systems with apparently random states of disorder and irregularities are actually governed by underlying patterns and deterministic laws that are highly sensitive to initial conditions. So chaos is a branch of mathematics focusing on the study of chaos whose apparently random states of disorder and irregularities are actually governed by underlying patterns and deterministic laws that are highly sensitive to initial conditions. So there are principles of chaos. The first is the butterfly effect. The butterfly effect, this effect grants the power to cause a hurricane in China to a butterfly flapping its wings in New Mexico. So, ang pag-flap ng wings sa butterfly is nakakause siya hurricane sa China. This effect grants the power to cause a hurricane in China to a butterfly flapping its wings in Mexico. So when the butterfly flaps his wings in Mexico, nakakause siya hurricane sa China. It may take a very long time, but the connection is real. If the butterfly had not flapped its wings at just the right point in space or time, the hurricane would not happen. So if ang butterfly wala siya nag-flap sa iya wings, so dili to siya mahitabo ang hurricane. um, so a more rigorous way to express this is that the small changes in the initial this demonstration of the conditions led to drastic changes in the result. So ang small changes daw siya, small changes of the in the initial conditions led to drastic changes in the result. So baka po siya, pag mag-change ang conditions, so magka-cause po siya results, mag-change po ang results. Then, our lives are an ongoing demonstration of this principle. Tama siya, kaya if ever na wala siya na-fluff ang butterfly, if wala mag-fluff ang butterfly, dili siya maka-cause of hurricane. Next is the unpredictability. Unpredictability, because we can never know all the initial conditions of a complex system in sufficient detail. We cannot hope to predict the ultimate fate of a complex system. So unpredictability is we cannot predict. For example, na ulan, di na to siya ma-predict. Dili ta makabalo if ever kanus siya mo ulan. Next is the order or disorder. Chaos is not simply disorder. Chaos explores the transitions between order and disorder, which often occurs in surprising ways. Order or disorder is not simply disorder. A mixing order / disorder chaos is not simply disorder. Chaos explores the transition between order and disorder, which often occur in surprising ways. So, ang order or disorder case is not simply disorder. So it's occur in surprising ways, kaya dili ta kabalo if ever kano siya moabot kay it's occur which often occur in surprising ways. Next is the mixing. Turbulence ensures that two adjacent points in a complex system will eventually end up in very different positions after some time has elapsed. Examples: two neighboring water molecules may end up in different parts of the ocean or even in different oceans. A group of helium balloons that launch together will eventually land in drastically different places. So example, a group of helium, imo siya ipalupad and mag-land siya in different places. So mo siya mixing. Mixing is thorough because turbulence occurs at all scales. It is also non-linear fluids can't be unmixed. So to siya, example is a group of helium balloons that launch together will eventually land in drastically different places. So, pag buhian to nimo siya ang balloon, mulan siya sa different places. Next is the feedback. Feedback systems often become chaotic when there is feedback present. A good example is the behavior of the stock market. As the value of a stock rises or falls, people are inclined to buy or sell that stock. This is in turn further affects the price of the stocks, causing it to rise or fall chaotically. So, ang feedback is, for example, palit ka o nagbaligya ka o food, then hindi mo ang feedback sa mga tao para if ever maka-affect siya sa price on sa stocks sa imuhang business like food. Then next is fractals. A fractal is a never-ending pattern. Fractals are infinitely complex patterns that are self-similar across different scales. They are created by repeating a simple process over and over in an ongoing feedback loop. Driven by recursion, fractals are image of dynamic systems. For fractal is, for example, you're going to mag-plant ka og trees, then wala siya ending kay pag mamatay ang trees, then dapat magpanapod ka magtanom because fractal is a never ending pattern, so wala siya ending na patterns. So that's all. It's all about modern geometry. Bye.